Hello, my name is Vijay Vincent William, DSC2409098. Today I'm going to present my Calculus 1 assignment of video presentation on application of derivatives, economics, Washer method, moments, and center of mass. The total cost function is a mathematical formula used in microeconomics to calculate the total cost of production for a quantity of output. It used to analyze the relationships of production and price of goods or services. Next is the marginal cost function. The marginal cost represents the change of total cost when raised with an additional unit of output. The purpose of marginal cost is to find the most cost-efficient level of production by checking the additional cost of each increase in output. When differentiation is applied to the cost function, it also leads to the cost per additional unit, or the marginal cost function, where you can take the change in total cost over the change in quantity of output, which is same to the differentiation of the cost function, dcx over dx. Next is the average cost function. The average cost function computes the mean of total cost and identifies the average value of per unit cost of production. You will have the average cost function of total costs, of total fixed costs, and total variable costs. Another formula to calculate the average total cost is the summation of average variable costs and the average fixed costs. And next would be the quantity of output. Now on the first example, the total cost incurred in operating a certain type of truck on a 500-mile trip traveling at an average speed of v miles per hour is estimated to be. So we will write the function CV, the cost function 125 plus v plus 4,500 over v dollars. Find the approximate change in the total operating cost when the average speed is increased from 55 miles per hour to 58 miles per hour. So the question will be asking us to find the change in total operating cost. Is to find this is the change of total operating cost. So from the formula of marginal cost will be the differentiation of cx over dx, and we have found that it's right over here, dx, which is the change of the average speed as it increases from 55 to 58. So we will subtract 55 from 58 to get 3 miles per hour. That will be the change of the average speed. And now back to marginal cost, we have to differentiate the cost function. So marginal cost will be 1 plus 4,500 v to the power of -2, and we were using the power rule of differentiation. Next, once we have the marginal cost, we're using this formula to find the change in total cost. So it will be marginal cost times the change in quantity of output. So dcx equals, so we'll write 1 plus -4,500 b to the power -2. Then as the dx is 3 miles per hour, we will times the marginal cost by 3 to find the change in total cost. So dcx equals, let's simplify this to v squared minus 4,500 over v squared times 3, and now dcx will be 3v squared minus 13,500 over v squared, and it is asking to find the approximate change in the total operating cost. So to find, we will have to insert the initial value of 55 into this change in total cost. Let's write this as C55, the cost function when we insert the initial value 55. So we have 55 squared to 500 over 55 squared. So now to calculate this, the change of total cost when inserted the initial value of 55 miles per hour, we will get negative 177 over 121, which from the question, it asks to find the approximate change. So we will estimate this to two decimal places. So DSC2409098, using a calculator, we will find negative 1.46. This is an estimate. 6 change in total costs. Now is the revenue functions. Revenue function Rx returns the revenue of the sales of X units for a product, for a unit of product. So Rx will equates to P times X, where P is the sales per unit times the quantity of units. So if you write it down, the sales per units, which will be P, and X will be the units, you'll cross it out and return the sales of revenue. Sales of revenue. The relationship between P and X is the demand equation, which solving it will require the unit price function P, which is the sales per unit. And the revenue function R can be expressed as Rx equals Px, and P can be defined as Fx, so X Fx. Now let's go on to an example. So first, the quantity of C-card wristwatches demanded each month is related to the unit price by the demand equation P equals, so let me write it out, P equals 50 over 0.01 x squared plus 1 on the interval 0, on the bounded interval or closed interval 0 until 20, where P is measured in dollars and X in units of thousand. So first is to find the revenue function R. So let's start with A. To find the revenue function R, the formula of the revenue function will be R equals Px, where we already have the P function. I'm gonna write down Rx. Px will be 50 over 0.01 x squared plus 1 times X, which the revenue function will be 50x over 0.01 x squared plus 1. And move on to the section B. And to find the marginal revenue function the differentiation of R. So to differentiate this, we will have to use the quotient rule. So marginal revenue will be Rx. Then to differentiate this, we will use the quotient rule of differentiation. If we were to differentiate this, it will be like 0.01 x squared plus 1 squared over, we'll write down like 0.1 x squared plus 1. The differentiation of 50x is 50 minus 50x, and differentiation of this will be 0.02x, and which will result the marginal revenue as negative 0.5 x squared plus 50 over 0.01 x squared plus 1 squared. Next is compute the marginal revenue with the inputted value of 2, which is 2 units in 2000, and interpret the result. So let's write it here. Now to calculate this, let's write down the R, the differentiation of Rx with the initial value of 2, which is basically the marginal revenue. So we will write as negative 0.5 2 squared plus 50 over 0.01 2 squared plus 1 squared. And this will result in R squared equal this. When we use our calculator, we will estimate the result as in 2 decimal places 44.8 238. This is our value. The total profit from sales can be determined by subtracting total cost from total revenue according to the profit function Px equals Rx minus Cx, where Px is a profit function, Rx is a revenue function, and C is the cost function. Next, to find the marginal profit functions, by applying differentiation of the profit function, we can identify the rate of change of the profits that gives insight into the profit or loss from the sales of units sold. MP is the marginal profit function. Px is the first derivative of the profit function. Next is the average profit functions. Similar to the average function of cost and revenue, the mean value of profit per unit can be defined by taking the total profits over the quantity of units. Now let's move on to the example of profit functions. The weekly demand of postal DVD records is given by the demand equation, where P denotes the wholesale unit price in dollars, and X denotes the quantity demanded. This weekly total cost function associated. So let's write it down. To find the revenue function R, the formula of R is X times P, or the demand equation, or XFX. So to find the revenue function, Rx would be X negative 0.02 X plus 300, and Rx would be negative 0.02 X squared plus 300X. And to find the profit function, we will have to deduct the revenue function, deduct the cost function from the revenue function. So Rx minus Cx equals Px equals negative 0.02 X squared plus 300X, then minus 3 times 10, negative 6 X to the power 3, negative 4 times 10 means square. X squared plus 200 X plus 7. Okay, now so this is the profit function. So to find the profit function, this will result in negative 3 times 10 to the power of negative 6 X to the power 3 plus 2 times negative 2 times 10 to the power of negative 2 plus 100x minus 70,000. And if we were to differentiate Rx will negative 0.02 X squared, X2 will goes down to negative 0.04 X by the power rule and by the additional rule plus 300 plus 300. This will be the marginal revenue function, and next would be the marginal profit function P, the differentiation of Px. So marginal function of P will be negative 9 times 10 to the power negative 6 X squared plus 4 times 10 negative square X plus 100. Function of C. So let's go to section C. It will be AC equals 3 times 10 negative 6 X to the power 3 negative 4 times 10 negative square X squared plus 200 X plus 70,000 from the cost function here, from this cost function. And to find the average cost function, so marginal would be by the power rule, so 6 times negative 6 X, then by additional rule, negative 4 times negative square, then this will be 1, and this will be negative 7,000 over X squared. Option D, we'll have to find the C, the marginal cost with the value 3,000, the marginal revenue with 3,000, and marginal profit with the value X, 3,000. 8 negative square 3,000 plus 200, as we just insert this inside 3,000 inside the marginal cost function, just minus 81 minus 240 plus 200, and it will result in 41. I'll write this down in a better way. 3,000 equals 41. To find the profit function, we will have to write it down as P 3,000 as this is same to the function of R 3,139. Next is the disk and washer method. Disk and washer method are used to find the volumes of solid revolution about an axis, whether it will be the Y or X axis. When a region is rotated around an axis, it forms a solid revolution. So it will form a solid revolution similar to a disk. The cross-sectional area perpendicular to the axis of rotation at any point is deducted as AX, and this area forms a cylindrical disk. Since the cross-section, so we'll take a cross-section, is a disk, the area is given as AX equals pi Rx squared. where Rx is the radius function. Rx will be the radius function, so Rx here, radius function. To find the volumes of the solid, we integrate this area over the interval defined by the boundaries of the region. First is to find the volumes of the solid obtained by rotating the region bounded by y equals x squared, y equals x to the power 3, y equals 8, and x equals 0 about the y-axis. And we will have to, if x equals to 0, y is equals 0 as well. So it's bounded by y equals 8, y equals 0. So it will be in a closed interval. It's not x, it's y. Pi r y squared dy. And then we can just pass in 0, 8 integration rule. So 2 over 3 plus 1. So this has to be 5 over 3. This will be 3 out of 5. Y, 5 out of 3. And it will be 8, 0. As the 0 section will be all 0. So 5, let's say all 0 and 8. 8 is 2 to the power 3. So that's 2 to the power 3 times 5 out of 3. It will be the other. So 2 out of 5 times 3 over 5, which will result in 96 pi over 5. Then center of mass. The center of mass is a point on a given plate where it balances evenly in the horizontal direction. By using the law of the lever, we can find the center of mass by using the formal definition m1 d1 equals m2 d2, which d originates from the distance of the fulcrum to the first mass and the distance of the fulcrum to the second mass. And this can be defined as a plane or point where the coordinates of the center of mass x1, the coordinates of the center of mass will be deducted by x1 to find the distance of this, and to find the distance of this will be x2 minus the center of mass, which results in this formula where we will just multiply in and we will take out the coordinates of the x to equals the m1 x1 plus m2 x2 over the summation of the masses. The center of mass formula can be defined as the summation of I equals 1 to n mi xi over the summation of the total mass of the system. It can also be written in this method. A system of particles with masses can be computed to find the center of mass. In a two-dimensional space, the moment of the system about the x-axis is this, and the moment of the system about y-axis is this, as it's similar to the equation up here as my over m, which will equates to mi equals 1 and mi xi over the total mass of the system, I equals 1, and then mi equals the x coordinate of the center of the mass. To find the coordinates of the center of mass is to individually find each coordinates of both x and y axis with the center of mass formula. X bar is the x coordinate of the center of mass, y bar is the y coordinate of the center of mass. Mx and my is the moment of the system in both x and y axis, and m is the sum of masses of each particle. Now in the first example, find the moments and center of mass of the system of objects that have masses 3, 4, 8 at points -1, -1, 1, 2, -1, 3, 2 respectively. So to calculate this, to find the coordinate of the center of mass, is to first find the moments. So to find the moments is to find mx equals the summation of, let's say, -1, 3. So by the x coordinate, we will calculate by -1, 2, 3 with the masses. So -1 times 3 plus 4 times 2 plus 8 times 3, which will result in -3 plus 8 plus 24 equals 29. The moments of the y-axis will be 1 times 3, -1 times 4, and 2 times 8, which will become 3 minus 4 plus 16, which equates to 15. And now to find the total mass is basically the summation of 3, 4, and 8, which is 15. And to find the moments, as we already found the moments, to find the center mass of the system object, we will have to find x coordinate, which is mx over m, which is 29 over 15, which is 114 over 15. Then y coordinate of the center of the mass will be my over m equals 15 over 15, which is 1. So with these coordinates, we have found that the center of the mass, with these coordinates, we have found the center of the mass, which is center of mass is located on the coordinates 114 over 15, then 1. So that's all. These are the references to the sources or the materials earlier. And thank you for watching from my video presentation of Calculus 1 on the application of derivatives on economics, this and Washer method, center of mass, and the moments. Thank you for watching.